Today we are going to study the topic models of structure of atom. Okay. So before studying this structure of atom, the different models. Okay, just revise it. Okay, Dalton, he said that yes, atom is not divisible. It doesn't contain any subparticles, isn't it? But later on, there was the discovery of what? The proton, electron and the neutrons. Electrons and protons were discovered earlier only. Okay, first protons were discovered and then electrons. Okay, don't get confused in that, because later on experimentally it was said by the scientists, but before only we were knowing about what the protons and then the electrons. Okay, now here Thomson came forward first to give the model of structure of atom. Okay, at that time what happened, neutrons were not discovered. Okay, so his atom said that yes, there is a positive sphere and in that the negative particles are there present. Okay, so his model is also known as Christmas pudding or watermelon model. Okay, have you seen a watermelon? Okay, whole green, isn't it? And inside the seeds are there. Okay, the seeds are compared with what? The electrons. Okay, and the whole body of that watermelon is known as what? The positively charged sphere. Okay, like that Christmas pudding. Have you seen Christmas pudding? That pudding consists of dry fruits in it. Okay, so that dry fruits are what? The electrons, and the structure is the protons. Okay, now he also said that yes, electrons are the dry fruits which I explained you, which is present in the sphere, and the positive sphere is just surrounding it. Okay, so positive charge and the electrons, when we are talking about watermelon, okay, the positive, I said to you, the whole body, the red portion, the green portion, all it is the positively charged, and the seeds are the negatively charged electrons. Okay, this was actually compared. Okay, so Thomson, he tried his best, because he had to say that yes, atom is electrically neutral. Okay, he said that yes, it is consisting of negative and positive charge. Naturally, they are electrically neutral, but nothing more he could explain. No experiments, nothing. Okay, so if no experiments, nothing, not explaining anything properly, where it is present, where it is not present. Okay, just saying that yes, electrons are embedded inside and the protons are outside. Okay, in the sphere. Okay, nothing else, no experiments. So later on Rutherford came and he gave his model. Okay, so now coming to the Rutherfords model of an atom. Okay, actually his full name is what? Ernest Rutherford. Okay, he experimentally gave them this model of structure of atom. Okay, so for his experiment, what did he do? He took gold foil and he took alpha particles. Okay, so when I am saying about gold foil, okay, it is a very thin layer. Okay, and it is about 1000 atoms thick. Okay, so when I am saying he took a gold foil which was very thin layer, only 1000 atom thick, why did he take this gold foil? He could have taken aluminum, he could have taken copper, he could have taken any other element or the metal. Okay, but he took only gold foil only. Okay, why? Because this is very malleable and ductile in nature, it is very thin in nature, and if it is very thin in nature, naturally if anything strikes it, it can give the result, isn't it? But next he took what? Alpha particle. So he took alpha particle. This alpha particle is comparatively heavy. Okay, now this alpha particle is actually doubly charged helium ions, which has got a mass of 4 atomic mass unit. Okay, these alpha particles are moving very fastly and having a great energy, large energy. Okay, so when this alpha particle would strike this thin layer of gold foil, naturally something can be seen. And what he assumed was that if he is taking alpha particle which is heavy, moving fast with a greater energy and striking this thin layer of gold foil, it will move directly, or it will move without any problem, okay, and it will move straight, okay. But surprisingly, this didn't happen, okay. He got a different result, okay. Now let's see. Yes, I said you about the experiment. I said something different happened surprisingly, which he did not expect. Okay. So what was that surprisingly? What did he see then? Rutherford, let us continue. Okay. So here he saw what? The fast moving alpha particles, they move straight. Actually here just listen to the experiment first. These are what? The atoms of the gold foil, this round spheres, okay. Same is here, okay, just magnified, okay. So now naturally alpha particles are moving. You can see most of the alpha particles, they are going straight, okay. Some we are seeing that yes, it is moving, but it is deflected by some angle. And some we are seeing what? Out of the every 12,000 particle, one of the particle we are seeing what? It is totally rebounding back. It means it is totally deflected back. Okay? Not making any angle or totally deflected back. Okay. This can be understood if we take an example of a blindfold boy. Okay? He is having stones in his hand and he has to throw the stones and the wall is in front of him. Okay? He throws the stone. Okay? He could hear the voice, isn't it? Produced by that stone, the sound produced by that stone. Okay, suppose a simple fence is kept in between. Okay, now he is throwing the stones. Okay, will he hear? No, because it will not reach there. It means some obstacle is there in between. Okay, and as the result, the stone is not reaching the wall, it is coming back only. And this can be compared with the experiment of Rutherford. It means something is present in the center because of which it is getting deflected. Okay. So what it is and what conclusion did Rutherford make, we are studying. Okay. Now, he did the experiment, made the observation, he saw what is happening, isn't it? And then he came to conclusion. Why actually this is happening, that most of the alpha particles are going straight. Okay. So, for this what did he say? Why it is going straight? I said to you, with the example of the boy, if the fence is there, it will not reach. It means some obstacle is there, then it is not reaching, and when obstacle is not there, it is reaching. And that only Rutherford made the conclusion that yes, most of the space inside the atom is empty. Okay. Nothing is present over there. So no obstruction. Naturally what happens, this alpha particles goes on straight. Okay. Now, next he saw what? That few are getting deflected with some angle. Okay. And there he said that yes, few are getting deflected. It means alpha particles are what? Positively charged. And if it is positively charged, naturally what will happen? If it is striking or going near a positive charge, it will be coming back, isn't it? Or it will be rebounding back. Okay. So both two. The one is where it is being deflected by angle of one by some angles, small angles, and another is it is rebounding back. Okay. So these two, he said that yes, few particles are deflected. Why? Because positively charged particles are present in the center. And if the particles of alpha particles are moving nearby to it, naturally there will be an effect of the positive charge, because alpha particles are also positively charged, and naturally if it is going near to it, it will be deflected by small angles. Okay. But if the alpha particle is going and it is going through the center of the atom, where the positively charged particles are present, okay, that is the protons, what happens? Alpha particles are also positively charged. Naturally what will happen? It will rebound back totally. Okay. So here, with this conclusion, Rutherford could say about the structure of the atom? He said only few alpha particles are rebonding back, few are showing the deflection. It means there is some positively charged sphere, okay, positively charged area inside the atom. Named it nucleus, consisting of protons. He calculated the radius of the atom and he said it is 10 to the power 5 times the radius of the nucleus. Okay, so radius of the atom is 10 to the power 5 times the radius of nucleus. It means nucleus is very, very small. Okay, now after seeing about the nucleus, he said that these negatively charged particles, electrons, they are revolving around what? The nucleus. Okay, and at that time these neutrons were not discovered. This also I will say to you. Okay, so he only mentioned about protons and electrons, how they are present, and he said that yes, it is electrically neutral because number of protons and electrons are similar. He could say that. He could also say that yes, some positive charges at the center, as the result the negative charges revolving around the nucleus, and this attractive force is holding them together. This much he could say. Okay, and he gave the structure of atom. He also said one thing, that yes, the total mass of the atom is present in the center or concentrated in the center of the atom. Okay, so these were the points which Rutherford said about the structure of atom. Now let us study about the drawbacks of Rutherford structure of the Rutherford model of structure of atom. Okay, he said yes, what? There is a positive center known as nucleus. Here what is concentrated? The mass of the atom. Okay, and the electrons are revolving. This was said by Rutherford in his model of structure of atom. Okay, so if this positive particles are present in the center, it's okay. Electrons are revolving around the nucleus. Naturally, if it is revolving, it is in acceleration. Okay, and if it is accelerating, naturally what will happen? It will release out energy, and if it is releasing out energy, naturally it is losing the energy. And if it is losing the energy and it is going on moving, naturally a time will come. It will fall into the nucleus of the atom. And can this exist? If it is falling, this atom can exist. The atom is a form of water. Matter consists of atom. And if this falls into the nucleus of that atom, these electrons, it becomes highly unstable. And naturally, at this position, matter can't exist. Okay, so his model of structure of atom was not correct, or this is the limitation of Rutherford, because he could not explain that yes, the electrons are revolving only, and why they are revolving, it is not falling into the nucleus. He could not explain that, and there it lies the drawback of Rutherford. Okay, and after Rutherford, who came? Niels Bohr came. He gave his model of structure of atom. Now, I said to you, yes, there were limitation or drawbacks of Rutherford, and who came then? Bohr came. Niels Bohr, his full name. Okay, and he gave the model of structure of atom. Okay, he gave the model in a very interesting manner. Actually, he took all the things of Rutherford only. Just the limitations, he renewed it, and he said in a different form. Okay, how he said? He said that only certain special orbits are there. Okay, and he named that orbits as discrete orbits. So what does this discrete means? It means it is consisting of different orbits with different energy levels. Okay, like he named the first orbit K, second L, okay, third M and N. And he said that yes, they are having, all the orbits are having some specific energy, okay. And as the result, these discrete orbits are only allowed. If there is a fraction or a negative, it will not be allowed, okay. So, as these orbits are having a definite energy, okay, these all k element, okay, naturally the electrons which are revolving around it will not this radiate the energy, okay. And if they will not radiate the energy, they are moving with that energy of the orbit only, naturally it will not lose energy and not fall into the nucleus, okay. He said that these orbits, what, or shells named, it is known as orbit also or shell, okay, have got specific energy levels. Electrons are revolving in that orbit, have that energy only of that orbit, and they are revolving with that energy only, okay, and naturally they will not lose their energy and fall into the nucleus. So, when we are talking about this, models of structure of atom in 9th level, you have to study it up till Bohr's model only, okay. So, hope you might have understood it. Good day, take care.